Never mind. It's okay. It's okay. It's okay. Okay, sorry for that. Good morning, everyone. How's everyone doing? Feeling good? Thank you for showing up. So this is just the beginning of the day, so I just want to do a quick show of hands. So who's here for the first time in Swift Heroes? Me too. Who came outside of Turin to join us today? Wow, that's a huge portion of the crowd. That's very exciting. And who's a developer in this room? Wow, okay, that's a lot as well. And do we have designers in the house? We have a few. Okay, that's good. And finally, who came here with some of their team, some of their teammates today? Oh, we have a lot of teams here. That's good. So this talk is very focused on you, on teams and your teammates, and how you can better synchronize your work with your design teams and your development teams together. So let's get started, but I'll quickly introduce myself first. So my name is Shai. I'm iOS tech lead for Gett, the on-demand mobility company. I do a lot of open source work, especially for ArcSwift and ArcSwift community, but lately I've also been involved in Combine community, which does open source work on top of Apple's new Combine framework. I'm also an international speaker, speak at a bunch of conferences such as this one, like Try Swift and Mobile Unplugged. And I'm also a huge fan of hackathons and even won a few. I'm also part of the iOS team at raywenderlich.com. We worked on a bunch of tutorials and books on their website. The last of them is the new Combine book, which I was a part of and I'm really proud of. Be sure to check these out. Go to the website if you're an iOS or Android developer. There's a lot of free content there, so feel free to check it out. So a bit about Gett. Gett is a leading global on-demand mobility company, and we have teams in Israel, in Russia, in UK, and the US. And the team I'm a part of is the Rider app team, which is the team where you actually book rides to drive with. And we're a very small team. We're just 7 iOS and Android engineers total. We have a total of 2 designers in our team. We serve hundreds of millions of rides, using dozens of screens in our app and hundreds of UI components. And the point of this is to show you that we are a very small team, but we do a lot of work, and we need to be properly synchronized together to get that done properly. So what will we actually talk about today? So this is really the story of synchronizing design and development teams together and our journey through that, all the challenges, hardships, and the solutions that we came up with that worked well for our team. So our entire journey started with a huge mess, obviously, right? So in 2018, we started a new journey to do a new rebranding of the app and also revisited some of our previous components and our development mechanism. And as we ramped up our development, we constantly ran into issues between the development and design lifecycle, in a way. So here are some of these issues, but not all of them. So first problem we have, communication is very, very hard. So if we have this design on screen, the designer would come and say, hey, can you update the button color to primary orange? And developer would be, I have like 26 different shades of orange in the app, and I don't know which of them you mean. Okay, and then we'll both cry together. So that's problem one. Problem two, color reuse is super, super hard. We would get this design, it would have a color on it, and then later we would ask ourselves, did we ever use this in the app? And we would say, I don't know, just copy paste this for the 1000th time. That seems fine to me. Third problem, widespread changes in the app are super, super, super hard. The designer would come and ask, hey, can you change all the primary orange in the app to red and all the title to 22 points? And we would say, sure, let me just find and replace manually the 1,000 times in the app where that happens. That seems fine. It's not going to take my entire week, of course. And again, we'll both be very sad about it. But as we know designers, it never ends there. They would come later and say, I actually don't like that red, so do you mind trying another one? And then we would both burst into flames, basically. Problem 4. So style changes are not synchronized between our platforms, and we serve a lot of platforms here. So if the designer asks, can you update the button to the new primary orange, on iOS it would have some color, and on Android, oops, we forgot to update the Android app, so now we're missynchronized on these namings as well. And finally, naming across the platforms is inconsistent. If on the design team we call it primary orange, on iOS it could be a fancy orange thing, and on Android it could be orange is my jam. And on web, who the hell knows, right? And same thing about textiles. It could be called some Helvetica Neue Light 24-point primary orange color, and I don't know what it's on iOS and Android. No one really knows. So these are just a couple of problems, but it's much wider than that. The problem is much broader than that. So how can we actually solve these problems in our team? Easiest solution is to start cleaning up the mess in the app and like in our workflow, basically. The way we chose to do that is with a design system. A design system for us is a shared set of colors, textiles, and components that can be used by all teams, design, iOS, Android, and other teams possibly. So the easiest way to go at it was to start with our design team. We had our design team, we worked closely with them, and they made a shared library of these textiles and colors and symbols that they can reuse inside Sketch. So people can constantly reuse them. So if they are updating this label, they would have preset options of the textiles that they can use for that, and then we have this reuse of colors and textiles. And that helped like designers. But what about us? What about the development team? Here's where all the problems started, basically. So what are the things that we wanted to solve? We want to keep design and development teams synchronized. We want a single source of truth for the colors and textiles in our app. We want to generate platform-specific code for iOS and Android separately. And we want the ability that the designers themselves would make these changes and push the code changes to us instead of us having to manually update it all the time. OK, let's do it. So we started at this point to look at some solution. But at that point, we looked at a bunch of different commercial options and a bunch of paid options, a bunch of free options. But we really couldn't find anything that fit all of these criteria. So after thinking about it for a couple of days, we decided, why won't we just build it ourselves? That's always the easiest way, right? So what would be a good single source of truth? That's where we started. Like, where can we derive design information from for our design system? And the answer was much simpler than we thought. Zeppelin. So Zeppelin is a really, really good source of truth because it has all of your colors, all of your textiles, and all of your UI in a single place. So if you choose some element, you would get a named textile for it, as well as a named color. So these things are not just values anymore. They actually have names that you can communicate with. And Zeppelin takes all of these different colors and textiles, and it makes them into a project style guide. And that looks like this. It's all of your colors, all of your textiles in a single place. So it seems like we have everything. We have a design system. We can go home. Thank you. No, wait. What about the code, right? We forgot about this tiny little thing. So at this point, we're missing a way to get some API information from Zeppelin so we can fetch these styles and transform them into whatever we want, some code, whatever we want. The problem is that Zeppelin has no API. So now what, right? So through some hackery, we gained access to Zeppelin's private API. I really love this picture, like hackers being with their hoods and everything, when in reality it looks much more like this. Thank you for the person in front of that was great. Anyways, so we finally have some data to work with at this point. We have some data entities from Zeppelin. This is just an abbreviated version of them. We have a project that has some ID, a name for the project, an array of colors and textiles, and each of these have their own RGBA colors and a name and an ID, and the textile also has a font size, font face, and a color that is linked to that color on the top. So now that we have some data, we can actually build something using that data. So we started building the tool. We started working on a Swift-based command line tool to generate this code for the textiles and colors using the Zeppelin API, the private Zeppelin API we discovered at that point. And we called it Prism. Prism as if the art prism where Zeppelin comes in and we shoot a bunch of code files out of it. So we started building Prism. We started building this tool. And we started with a really naive implementation. We just defined a simple protocol where you would get generate textiles, generate colors, and you would get textiles and colors, and you would have to spit out some code based on them. And then on iOS, you could implement a simple option like this, where you would iterate over all the colors, and spit some static let for each color with a UI color initializer with RGBA values, as well as the textile. The same thing, we'd go over. Oh, this doesn't work. Oh, it does work. We generate the textiles for each of them. We could have our own textile with the textile font name, font size, and the color, the name of the color that's linked to this color on top. And then when you would run the tool, you would get something like this. It would generate all of the colors from Zeppelin using UI color initializers in our case, because that's what we define in our protocol definition, in our conformance to that protocol of the iOS style guide. So this actually, we also did the same for the textiles, obviously. This is how it would look when you would generate the textile Swift file from that same protocol conformance. This worked pretty well for a while, but that started to get problematic as we started bringing the Android people in the house, because they saw it and they also wanted to use it. So we had a couple of snafus while working with them. A couple of issues we had. It would require our Android developers to actually learn Swift to make their own templates, their own style guide, because they would need to conform to that protocol and add that class for the Android style guide. Every new consumer of the app will need its own new class, like an Android style guide that conforms to that protocol, and would require actually updating the tool itself. You would need to add a new Swift file to Prism and recompile it whenever you want a new style guide. Changing these style guides requires deep knowledge of Prism's code base itself. You really needed to know the entire tool to make your own style guide, which is a huge problem, because we wanted it to be much easier. It had a very long development cycle, because every time an Android developer that just learned Swift tried to make their own style guide, they would have to recompile and they would have to rebuild the tool, and that was just a very long development cycle. And finally, the style guide files themselves are owned by the Prism source code, because they're Swift files inside Prism, and they should be owned by each individual project, which wasn't the case. So it's not a bad solution, but it wasn't perfect. It wasn't good enough. It wasn't what we wanted to do. So back to the drawing board. How can we improve Prism? So we needed a way to deliver a code that we can produce our color and text files from, that's flexible and fast, that's easy to create, that doesn't require any code changes inside Prism itself, that it's hosted with each individual app, and finally that it's synchronized from a single source of truth. We started thinking, what fits all of these that doesn't require any coding knowledge, doesn't like any specific coding knowledge, doesn't require any code changes, and we can host easily with each app? And the answer was pretty simple to that: templates. We started working on our own templating engine to solve this problem. So we introduced a very simple stencil-style template that lets you iterate over these colors and text styles and create any output you want using a set of tokens that looks like this, with the curly braces and the %. And when I say anything, I mean you can create anything. Prism doesn't care. It only takes the template and spits out whatever you want from it based on your colors and text styles. So here's a quick example. But before that, when you would run the Prism tool inside a folder, it would look for this .prism folder, and it would process every template it finds there. So the .prism files are templates. We would run the tool, and we would get generated the Swift files that these templates are based on. And that's the basis of how this tool works. So you can easily create this template as follows. You just have Prism doesn't know this is a Swift file. It's just a text file, a plain text file as far as it's concerned. It sees this extension, and then it sees this for loop. And we'd iterate over all the colors. For each color, it would create this static let with the UI color initializer, passing the RGB and alpha values of it. An interesting thing is the color identity is using the camel case identity. So it is specific to the iOS naming convention as well. And finally, we have the end color, and that would iterate over it over and over until it prints out all of the colors. Prism translates it into the same color Swift file we saw earlier, just iterating over it and printing out all of the colors based on whatever template you defined. The textile Swift Prism would look very similar. We'd iterate over all the textiles. We'd have the identity, in this case also a camel case identity of the textile with the font name, the font size, and the color identity, which is linked to that same color. So they are sharing the same names and the same colors in our code base. When Prism processes that template, it would look something like this as well, similar to what you saw earlier. So this is great. We didn't really introduce any changes to our Swift code base. Everything looks the same. But now that we have a templating engine, we can easily do the same for our Android team. We can introduce a template that looks like this. A colors XML Prism file, where for each of the color, we'd have a color name, color identity. In this time, we have a snake case identity, because that is specific to the Android naming convention. And also the colors, instead of using independent RGBA values, we use the ARGB namespace here, because that's what Android uses. So this templating engine is also very, very flexible into everything you could need in a design system. Prism would take this template and it would make this sort of colors XML file every time you run it based on your Zeppelin style guide. As you see, the naming is specific to Android and the colors are also ARGB formatted. You can do the same for the text styles on Android. For each text style, print the style, text style identity snake case as well, with the font size, font name, and the identity. But here we had a tiny problem. The font name was called graphic Gett-regular. And what Android actually needed is everything to be lowercase, and they didn't use dashes, they used underscores. So to solve this, we introduced another option here, where we can have various transformations piped to any token in our system. So here we are piping lowercase and replace. The first would just lowercase the font name, and the second would replace every dash with an underscore. So that kind of solved our problem, and we have a bunch of these that you can use for anything in this template. When you run it, you would get something similar to the following. Again, you have a body default dark, and you can see that the font name is, as you would expect, lowercase with the underscore. So great, this really solved our biggest problem. A designer would come and say, hey, can you update the label style to the title medium default dark? And iOS and Android would both say, yes, sure, because we both have statically typed and pre-generated colors and text styles. We can't get confused and we can't mispick the right styles. We have everything we need to solve this problem here. But why stop there? Now we have a template. Again, we can make anything we want. So if you want to just have a web page showcasing your entire design guide, very easy to do that. Just make an HTML template. Again, as I said, Prism doesn't care what the output is. It just knows it's looking for these tokens, and it would print out whatever you want. So here it would iterate over all of the colors and spit out some divs. And for each text style, it would print out some span with that text style. And when you generate it, it would show something like this. Sorry, I'm not a web developer. This is ugly, I know. You can do better. But yeah. But the point is to show you that you can generate, again, anything visual or non-visual or code or images or anything you want using this templating engine. And when I say anything, I mean anything. You can make some Dart code, you can make Android code, you can make CSS, Sass, anything, because Prism doesn't care. It only looks for the raw template, the tokens, and spits out anything you want from that point on. So let's review our list of goals up to this point. So communicating and naming over styles and colors, we solved that. We all shared the same naming conventions now. If it's called title, medium, dark on the design, it's also called the same on iOS and Android. Color and text style reuse, it's now entirely reused because we don't have that question of where we ask, hey, did we ever use that color? We have names for each of these colors, so it's obvious that we have used them and the designers know how to communicate that to us. Easy widespread changes. Again, now that a color is named, if we have a primary color we want to change, we would just change it to Zeppelin, regenerate the code, and it changed throughout the app wherever it was used before. Flexible, fast, and easy to create. Again, the Prism templates are just simple text files. So it's very easy to create for your own language without having any Swift knowledge. You can just create the templates, put the tokens in, do a loop over all of your colors and text styles, and spit out whatever you want and need for your use case. It doesn't require any tool code changes because it is just a text file that you put in your own repository with your own app project. And as I said, it's hosted with each individual app inside that .prism folder. It's associated with each of your projects. There are two final points we didn't solve yet here. The first is that it should be synchronized from a single source of truth. And the second is that the designers can push these changes to the developers themselves. So at this point, we said, let's take it up to 11, solve the last two problems. And the way to do that is to automate more things, obviously. So how do we automate and what do we automate? We're missing really one crucial point. We would like to be able to automate the way we generated these pieces of code using Prism, and we want to let the designers trigger these updates so they can push changes to us and close the entire loop. We would want the designers to make the changes, have Prism run somehow, and that automatically would make a pull request for us that we can approve and merge based on what we need. So to do that, we needed some safe environment that can host the Zeppelin token, the project ID, and other secrets, that has access to our GitHub repository so it can create a branch, make the changes, make a new pull request, and all of that. That it can build and run the tool itself, Prism, and that it can be triggered remotely via an API, so we can trigger it remotely. And when we looked at all of these things, it made sense that we need some sort of a CI environment with a good API. In our case specifically, we've been long-time users and fans of Bitrise, and that kind of covered everything we needed for that use case. So we decided to make our own custom Bitrise workflow to leverage what we built on Prism. So it started with some Bitrise workflow that injects the Zeppelin token, project ID, and every other secrets. And the great part is that because Prism is built in Swift, it doesn't have to be a macOS machine. You can build it on a regular Linux machine as well, because Swift works on Linux as well. Then it would clone the project and make a new branch to have the design changes on top. It would then run Prism. Prism would go over all of the templates and generate code based on the latest values in Zeppelin. So you'd have the latest colors and the latest text styles applied to your templates. With these changes, it would create a new commit and a new PR with Hub, which is GitHub's command line tool that you can use to create pull requests, etc. And between all of these, we also run some Slack notifications. When the generation starts, we would send a started notification, and when it ends, it can end in any of three different options. Either it was successful, we had some updates to our design system, or, oops, sorry about that. Oh, that happened. No worries. So yeah, either it started, either it was successful, either there were no changes at all, meaning that the Zeppelin style guide and the code in your app are exactly the same, or it failed for some erroneous reason. So we then also built another tool for the designers themselves, an app that they can install on their computers, this status bar icon. And then the designers themselves can make the changes, just press any of these icons and any of these options and start integrating that Bitrise workflow, triggering it, and generating that code for us. So they don't need to know anything happening behind the scene. They just tap this button, it runs the workflow, and does all of the work for them. So as a quick recap, this is what's happening. We have the designer that makes some style guide updates. They change the colors and the text styles in the app. We then have the status bar icon where they pick either iOS or Android Bitrise workflow, and they just trigger that and it starts working. When it starts working, the CI would run Prism and generate the code to update everything. That would eventually create a PR and send a Slack notification to the design system channel in our Slack. Developer only has to review that generated code and merge it if everything looks good. So this is how the notifications look. You can see that here it says that the build started, it's ongoing, and here it says that it was successful, and you also can see the pull request itself, so you can immediately press the link and approve it. This is the state where it was aborted because the style guide and your code were identical, so no code changes were needed. And finally, for a failure, in this case, the failure is that the designer tried to create a white color, and that name is reserved on iOS. So we also know to catch these scenarios and fire an error for this so that the designers don't have to mess with the tool directly and know exactly what they need to change. For the pull request, it looks something like this. It would have some automatically generate design content. It would label it with a design label and ask everyone in the team to review it immediately so they can interact with it. And they can see this code. In this case, we had two colors added, some accent blue and a gray 50, and had a couple of new text styles. And we, as developers, can immediately review this, merge this, and have everything synced to our Zeppelin designs in this case. So this really solved all of our problems. We have automation, we have synchronization between design, iOS, and Android, and we can always sync together to make sure everything looks good on screen and looks the same as the designs that we have. So from here, what is the future for Prism? We started thinking, what else can we do here? So the future, as we see it, is that except for textiles and colors, Zeppelin has this concept called components. And it's just the simple UI component, or it can be an entire screen, or anything atomic enough, I guess. And that also is exposed via their private API in a way that you can have information about it. So we thought it can be really awesome to go through all of these UI components and be able to generate entire components based on these specs. So you can have access to these via the templates and say, I want to generate this following SnapKit code or this following NS layout constraints, and create this entirely in an entirely generated way. And once you have these smaller components, you can very easily have automatically generated entirely screens that are based on these smaller components. So this is really the future and what we are expecting to work on, and that's very exciting, and I think it would be a very huge time saver for our workflow as well. So it's time for the question that I hope you've all been waiting for. Are we actually going to open source Prism? Because we really want everyone to try it as well. So this is where things get a tad tricky. Since we're using Zeppelin's private API that we're not supposed to use, there is a bit of a legal issue here. We want to share the code with the world, and we were very sad that we realized that there's a problem with that. Sad, yeah. So, but then really something happened, something very surprising happened. We reached out to Zeppelin, and they really liked the idea, and they really wanted to cooperate with us, and they mentioned they're working on a public API that's going to be released soon in a private beta in the middle of December. At that point, we can integrate Zeppelin with the official API and have everything working with official APIs, working well for all of the teams. With that, we're really happy to announce that we plan on open sourcing Prism somewhere at the beginning of 2020, and we can't wait for everyone to use it. And it saved so many hours for our team, both in terms of frustration and both in terms of being properly synced without a lot of mess. So let's wrap up. First of all, when we have many sources that conflict, define a single source of truth and derive from that. And that's not only true for design, it's true for code as well, right? The less sources of truth you have, the less problems you would have. If you have some recurrent action that wastes time or creates a lot of friction, you should automate it. And if the tool doesn't exist, don't be afraid creating it yourself. It's not as horrible as you would think, and the journey is awesome. Trying to create a tool and seeing your friends use it and seeing your teammates gain valuable time based on the work you did. And building developer tooling in general is very, very fun. You should try just messing with everything, working with your teams and everything. Working with the other teams that will actually use this tool is crucial. If we would build this tool without consulting with the design team and the development team to make sure it fits the purpose, at least some of the people, it would be very problematic because we could ship the tool and no one would know how to use it and no one would think it's useful. So having that communication is super, super important early on when developing the tools. And finally, we can't wait to see how the community uses this. I think it's going to be really awesome and save everyone a lot of time, and I'm looking forward to sharing it with you and see your feedback and how you would want to improve it and how you would want to evolve and change this tool in the future. Finally, before we wrap up, I want to give a huge thanks to Dane Barr and Karen Hossie. They were crucial as part of our design team to work on this system, and without their support, it would be very hard to ship this. And of course, thanks to all of Gett's mobile R&D team. And with that, thank you very, very much. You can reach me on Twitter, Facebook, and GitHub.